Yeah, let's look at probability, guys. Now, whenever I talk about probability, okay, so probability is nothing but the chances of occurrence of the event. I'm sure we all know this. So the formula to calculate probability of any event is nothing but number of favorable outcomes divided by total number of outcomes. Right? And now the probability of any event would range from 0 to 1. Where when I talk about 0, 0 is the event will definitely not happen. And when I talk about 1, 1 is nothing but a certain event. That means the event will definitely happen. The third simple thing that we need to know about probability is probability of the occurrence of the event plus the probability of the non-occurrence of the event is always equal to 1. Now, there are three simple things that we will be applying in probability altogether, right? So, apart from a few models that I will see in today's class, probability actually can be, used in place of permutations and combinations. Reason being, as an examiner, I would rather give you a question on PNC on probability than a question on PNC. Suppose I give you a question like if all the letters of the word equality are arranged, EQUALITY, okay? Find the probability that if one word is chosen, that word has all the vowels together. One word chosen has all the vowels together. Okay. Now, what is the favorable outcome here? The favorable outcome is I want all the vowels being together. So if all the vowels are together, we know that is 5 factorial into 4 factorial. So from all these words, if I pick one word, then I will have a favorable outcome divided by total number of outcomes and how many ways the word equality, the letters of the word equality can be arranged. Now, this is how the question gets innovated or transformed into a probability based questions. Apart from all the questions that we had seen in permutations and combinations, we will see the separate models which are involved in this topic, right? And the first such model is dice. Do not start solving this. Let me just give you an introduction of dice. So whenever I talk about dice, okay, when I throw one dice, the number of outcomes are going to be 6, which are going to be 1, 2, 3, 4, 5, and 6. Now, when I throw a fair die, which means the events are equally likely. Now, what do we mean by equally likely? Which means the chances of each and every number, the occurrence of each and every number is same. Okay, that is what I mean. That is what I mean by equally likely. So the probability of one being, one coming up on the top when a dice is thrown is 1/6. 2 is also 1/6. 3 is also 1/6, and so on, so on, so on. This is called equally likely events. Okay. Now, if I throw n dice, the total number of outcomes are 6 to the power n. If you throw 2 dice, you get 6 square, that is 36 outcomes. If you throw 3 dice, you get 6 cube, that is 216 outcomes, and so on and so on and so on. Clear? So when I throw 2 dice, generally the question keeps coming about throwing 2 dice. So when you're throwing 2 dice, what are the total outcomes, guys? The total outcomes are 6 square, that is 36. Now, how does that come down to? So I write, let's say 1, 1, 1, 2, 1, 3, so on till 1, 6. Similarly, you have 2, 1, 2, 2, 2, 3, so on to 2, 6, and then 6, 1, 6, 2, 6, 3, so on till 6, 6. Now, this is what we are looking at whenever we are looking at a question on dice. Clear? So, if you see this, now whenever I talk about sum of the faces, the minimum possible sum will be equal to 1 plus 1, that is 2. And the maximum possible sum would be equal to 6 plus 6, that is 12. This is the minimum basics required to solve a question on dice. Okay, guys. Now can we solve this question, please? Yep. Now let's see this, guys. So if I want the sum of the faces as 9, okay, if the sum of the faces is equal to 9, then I'm talking about a plus b is equal to 9. So I know that since 6 is the maximum possible number, I can get 6 plus 3. Now two fair dice are thrown, which means two distinct dice are thrown. So I can have 3 6 or 6 3. Similarly, I can have 4 5 or 5 4 as the possible outcome. So there are only 4 favorable outcomes. Divided by when two dice are thrown, there are a total of 36 outcomes. Therefore, the probability of getting the sum of the faces as 9 is equal to 1 by 9. Clear, guys? Can I move forward? Yep. Can we get this answer, please? Very simple question. You hardly need 30 seconds for this. The same number on both the faces. If the same number on both the faces, then I'm talking about 1 1, 2 2, 3 3, 4 4, 5 5, or 6 6. That means how many outcomes do I have? I have 6 possible outcomes. Total outcomes are 36. So 6 by 36, my answer becomes 1 by 6. Yep. Can we solve this question, please? Take a minute. Yeah. When two fair dice are thrown together, find the probability that exactly one of the dice shows an even number. Now, the point is when two fair dice are thrown, now there's a possibility that the first one can have an even number. If this can have an even number, I can have 2, 4, 6 here, which means the second one has to have an odd number. If the second one has to have an odd number, this can be 1, 3, 5. So the total number of outcomes are 3 into 3, that is 9. Similarly, there's a possibility that the second die can have an even number. So again, this will get reversed, exactly reversed. So this is 1, 3, 5. So therefore, the total number of outcomes are 3 into 3, that is 9. Which means our total possibility of 18 cases out of the total possibility of 36 cases. Therefore, the answer is going to be 1 by 2. Clear, guys? Yep. When I throw coins, now what happens here when I throw coins? When we throw coins, the probability of getting a head when I throw one coin is half. And the probability of getting a tail when we throw one coin is also half. Clear? If you are tossing n coins, then the total number of outcomes are 2 to the power n. Right? Keeping this much in mind, can we start solving this question, please? Yep. If I'm throwing 3 coins, okay. Now, remember this way of solving it here. I don't want you to list down all the number of outcomes. Suppose the coins are A, B, C. Suppose the coins are A, the coins are B, and the coins are C. Now, I want exactly 2 of them to have a head. So, my first question is which 2? So, therefore, which 2 will be determined by 3C2? It can be AB, it can be BC, or it can be AC. Now, whichever 2 I select, in each of them, I need a head, that is 1 by 2 into 1 by 2. And the third one, I need a tail, and the probability of getting a tail is also 1 by 2. So, therefore, our answer becomes 3C2 divided by 2 cube. Clear, guys? So, this process is more or less standard when you keep on going for higher number of coins also. Let's see and solve them, please. Can we solve this, please? Exactly one heads if 4 coins are tossed. If 4 coins are tossed, we want only one head, which becomes 4C1. In that, you need a head that is into half. In the remaining 3, you need a tails that is again into half, again into half, again into half. So I repeat, that's going to be 4C1 divided by 2 to the power 4. Yep, can we solve this, please? Yeah. So same extension, I want exactly 2 heads. If I want exactly 2 heads, then the formula becomes as usual. That's going to be 4C2 divided by 2 to the power 4. Once you understand the logic, then it becomes very easy, guys. It's 2 to the power 4 side. Yep. So at least one head is what the question says, not exactly one head. At least one head we have learnt already. So at least one can be written as total minus no heads. Now total probability is always 1. Now when I say no heads, which means I want all the 5 tails, that is 1 by 32 is the probability of all the 5 tails. So 1 minus 1 by 32, your required answer is going to be 31 by 32. Okay, guys. Now exactly 3 tails is quite simple, guys. So we're not wasting too much of time here. So out of 5, I want to see which 3 in tails and the remaining 2 will be heads, and therefore the answer becomes 5C3 divided by 2 to the power 5. Clear? One last question on coins. Can we solve this, please? Quick, guys. Yeah, so I want a head in each throw if I'm tossing 5 coins. So in the first one, if I need a head, the probability is 1 by 2. I need a head in the second one. I need a head in the third one. I need a head in the fourth one. And I also need a head in the fifth one. So therefore, the answer becomes 1 by 32. Clear? Now, when I move to cards, which is again one last model of very basic models of probability. So let's understand the basics of cards also. I have a total of 52 cards divided into 2 colors. One is black cards and the second one is red cards. Now, each of them are of 26 and 26 cards. Now, black are further divided into 2 parts. One is clubs and the other one is spades. And the red is also divided into 2 parts. One is diamonds and the other one is hearts. Clear? So each of them is 13, 13, 13 and 13. Clear? Now, what are these 13 cards? My 13 cards are number cards. So you have 9 number cards. What are 9 number cards? 2, 3, 4, 5, 6, 7, 8, 9 and 10. All these are my number cards. Clear? And then there are 4 honor cards. Okay. Honor cards are 4 in number. That is A, then we have J, and then we have Q, and then we have K. So these are my 13 cards in all. Apart from this, there's one more terminology that we need to know is something called a face card. Now, face card are only 3. That's called JQK. So this is the complete breakup of all the cards. Can I have a minute and solve these questions, please? Yep, I'm sorry, guys. I did not realize when did that get changed. Yeah. So let's see this, guys. So if I want a black card, how many black cards do I have? So I have 26 black cards out of 52. So the probability becomes 26 by 52. I want a king. How many kings do I have? I have 4 kings. So that becomes 4 by 52. We want a black king. We know that there are only 2 black kings. So 2 by 52 becomes your answer. We want a spade or a king. Now, a spade or a king, whenever I use the word or, it is always probability of A union B. Now, probability of A union B would be probability of A plus probability of B minus probability of A intersection B. So, probability of it being a spade is 13 by 52. Probability of it being a king is 4 by 52, and a spade king is going to be minus 1 by 52. Clear, guys? And it being an honor card, we know that there are 4 honor cards in each suit. We have 4 such suits, so we need 16. 16 by 52 becomes your answer. Clear? Can you proceed? Great. Let's move forward, guys. Yep. Can we look at this model, please? Take a minute. 2 questions, 1 minute. Let's see this, guys. So we have 2 cards have to be picked simultaneously. When it says simultaneously, which means I'm picking them together. Okay. What is the probability that they are of the same color? Now understand the thought process, guys. How many colors do I have? I have 2 colors. So which color out of the 2? I do not know, right? So I'm first choosing a color. It can be a black or it can be a red. So therefore the color can be chosen in 2C1 ways. Once I've already picked a color, now there are 26 cards out of that color. So I say 26C2 divided by 52C2. This becomes my answer. So the answer of the first one is 26C2 by 52C2 into 2 will be your answer. Is this point clear with all of us? Great. Now let's move to the next one. They are of different colors. Now since I picked them simultaneously, different colors means I'm looking at a black and a red. Now we are picking up together, so I can't say the first or the second. Okay. So the probability of it being a black card is 26C1. Probability of it being a red card is also 26C1. Total probability becomes 52C2 becomes your final answer. Clear, guys? Can I move forward now? Very beautiful question, guys. Spend a minute, please. Yep, let's see this now. It's a beautiful question, guys. That's why I gave you a good amount of time. Now, go step by step. You have number cards. Okay. So each, how many numbers do we have? How many number cards? We have 9 in each suit. So total is 36. From 36, I'm picking up 2. Okay. Let's go step by step. They should be of same number. So first I'll choose one number out of 9. That is 9C1. Okay. Now it says that it should be of different colors. So I have to choose which one of the colors. So let's take an example. Suppose I'm picking up a 3. If I'm picking up a 3, it can be 3 of a red or it can be 3 of a black. Okay. Now how to go further? Suppose it's 3 of a red here. Then what happens? Black also, there are two options. Either you can have a 3 of a club or you can have 3 of a spade kada. So therefore, further you have two more suits in that color, and which one would be the one is again looked at by 2C1. Clear? So total number of favorable outcomes becomes 9 into 4, and total number of outcomes becomes 36C2. Is this point clear with all of us? Okay. Aditya, did you listen to the complete one, Aditya, last one? So which part is it out now? Na? Adugu. It has to be of same number. This part is representing number. It has to be of the same color. This is representing which color? Now, if you're picking a 3 or 3 and a red, it has to be black. In black also you have two further suits kadama. So any one out of these two kada. So therefore into 2C1. From a pack of well shuffled cards, two cards are drawn. Total number of outcomes 36 C2 kadamma. Sai charan 9 number cards in each suit. 9 into 4, 36 number cards kadamma. Number cards ఎన్ని ఉన్నాయి each suit లో 9 kada 2 to 10. Charan, waiting for your responses. What is the first sentence telling, Charan? Chadkunawa question. What is the first sentence talking about? Yep. So this says from a pack of well shuffled cards. That means I need to take all the cards. The previous question says you have only number cards. That means you have to take only number cards. Okay. So two cards are drawn in succession with replacement. Now this is again a catch here. Succession means one after the other. So first I'm picking one card from 52 cards. I'm replacing it. So in the second case also I'm picking up one card out of 52 cards. The first one is a queen. If the first one is a queen, I'm taking 4C1. I'm replacing it back. And the second one is a card of hearts. Since I'm replacing it back, I have the whole pack of cards again. So there are 13 heart cards. And therefore your answer becomes 52 by 52 into 52. And the answer is 1 by 52. Clear, guys? Yep, let's see this. You have 4 red balls, 5 yellow balls, and 3 blue balls. 2 balls are drawn without replacement. Okay. So after the first ball is drawn, 3 more red balls are added to the bag. So slightly changes here, right? So I'm talking about red, I'm talking about yellow, and I'm talking about blue. And the question says, what is the probability that both the balls drawn are yellow? So that means I'm drawing the first ball out of 12 balls, and it has to be a yellow. So I'm drawing a yellow ball for sure, and I'm not replacing it. So yellow ball gets reduced here. So you have 4, 4, and 3. Now 3 more red balls are added to the gang, which means now I have 7, 4, and 3. That is 14 balls in all. So out of 14, I'm choosing one, and the second one has to be a yellow ball. So therefore, it has to be 4C1 into 14C1. Clear, Tejasvi is not replacing Amma. Clear, guys? And it's multiplication, it's not addition, because he's taking one and the second one. He's doing both of them together. He's not doing this or this. Clear, both of them have to happen, so both of them are independent, both of them are dependent activities. Yeah, fair enough, Amma. Can you look at this question, please? Easy question, just a bit of lengthy one. A lot of drama is given, nothing else. Now, ABC, bag A contains 2 green balls, bag B contains 4 red balls. So, okay, A contains 2 green balls, 4 red balls, 1 white ball, and 3 black balls. Okay. If 3 balls are drawn from bag A, what is the probability that at least one is a black ball? If I'm talking about at least one being black ball, can I say total minus none? Total minus no black ball will be the case. So if total minus no black ball will be the case, that means what are we looking at here? So we will be looking at total probability is 1 and no black ball, which means I'm picking 1 ball from the remaining, sorry, we are picking 3 balls from the remaining 7 balls, and the probability is 10C3. Clear, guys? Let's solve this. Yep. Now we are picking from bag C here. Okay. So when I'm picking from bag C, both of them should be green. Now bag C has 3 green balls. So out of 3, I'm picking 2 green balls. So 3 plus 1, 4, 4 plus 4 is 8, 8 plus 2 is 10. So this becomes 10C2. Clear, guys? Yeah. Shall we consider the probability of 1 by 3? No, yeah, because you're picking bag C, no. See, if you do not know which bag is this, then you are saying 1 by 3 amount. But here you know that you are picking a bag C or a bag B or a bag A, and I know that those are named ABC. Arthamainamma? That's like a particular bag. Yep, let's see this, guys. So bag B, okay, bag B has 4 green. Then 3 red, 3 white, and 5 black. You're picking 4 balls, and what is the probability both of them are of the same color? Now, there's a possibility that all the 4 of them are of green, or all the 4 of them are of black. So that's 4C4 divided by 6 plus 5, 11. 11 plus 4 is 15C4 plus 5C4 divided by 15C4. Clear, guys? Yep. Can we solve this model, please? Yep. Now, the probability that work gets done. Now, here this is a case where we are applying the probability of A doing the work if it is 1 by 3. The probability of A not doing the work is 2 by 3. Okay. Similarly, probability of A doing the work is 3 by 4. Probability of B not doing the work is 1 by 4. This is what we are going with, one concept. Okay. What's the probability that the work gets done? Now, there are two cases in which the work will get done. The first case is, let's say exactly one of them is doing the work. If exactly one of them is doing the work, I would say A is doing the work and B is not doing the work, or B is doing the work and A is not doing the work. So A doing the work is 1 by 3 and B not doing the work is 1 by 4, or A not doing the work is 2 by 3 and B doing the work is 3 by 4. Sorry. Yeah. This is exactly one of them doing the work, which answers our second case also. Now, the other case is also that both of them can complete the work. If both of them can complete the work, then A comes and completes the work, so does B. That becomes again 1 by 3 into 3 by 4. So these are the three cases in which the work will get over. So we are done with the first answer also, and we are done with the second answer also. There is one more way here. The probability that the work will not get over, the work will get over is total minus work not getting over. Now, work not getting over is A does not do the work and B also does not do the work. And total case is 1. So 1 minus 2 by 3 into 1 by 4 also will give us the answer. Clear? Any doubts? Yep. You have tokens numbered 1 to 100. What is the probability that a token being picked is divisible by either 2 or 3? Now, I can repeat OR concepts of probability of 2 union 3, which would be probability of the coin being divisible by 2 plus probability of the coin divisible by 3 minus probability of the coin divisible by 2 and 3 both, that is 6. So how many coins are divisible by 2? So 2 into 1 till 2 into 50. That means 50 coins are divisible by 2. 3 into 1 till 3 into 33. That means 33 coins are divisible by 3. 6 into 1 till 6 into 16, which means 16 coins are divisible by 6. So 50 plus 33 is 83. 83 minus 16 is 67. 67 by 100 becomes your required answer. Clear? You're not picking two coins, Tejasvi. You're picking only one coin, Amma. And it's saying 2 or 3. A union B concept, Amma. Yep, let's see this, guys. The product of the digits is equal to 0. So can I say in all these cases, the product of the digits will be 0? It will be only 0 if one of the numbers is 0. Because 0 into anything gives me 0, right? So 9 of these numbers, out of how many 2-digit numbers we have? We have 90 2-digit numbers. 99 minus 10 plus 1. Clear? So 9 by 90, and therefore the answer becomes 1 by 10 here. So the product of the digits is equal to 0 if it is possible only when one of the numbers is equal to 0. And if I'm talking one of the numbers being 0, that is only possible in 10, 20, 30, 40, 50, 60, 70, 80, and 90. Am I clear, guys? Can I move forward from here? Last few questions, guys. I guess after this, 2 or 3 more. Yep, if two letters at random from the letters of the word mobile are selected, what is the probability that the pair of letters selected were adjacent to each other as given in the word? Which means what as given in the word means I'm picking up MO, or I'm picking up OB, or I'm picking up BI, or I'm picking up IL, or I'm picking up LE. That means I'm picking up two letters, right? So I have to pick either 1, 2, 3, 4, 5. I can pick any of the 5 pairs divided by 6C2 becomes your answer. Total number of letters is going to be 6C2. Can we solve this, please? Just take 1 minute, guys. So this question says you have 7 engineers and 4 doctors. 7 engineers and 4 doctors. Uh, 4 persons are selected. I want more doctors than engineers, so I can have 4, 0, or I can have 3, 1. That's it, because 2, 2 is not acceptable. 1, 3 is also not acceptable, and 0, 4 is also not acceptable. So engineers would be 7C0 into 4C4, or this will be 7C1 into 4C3. So either this case or we are looking at this case. Clear, guys? Divided by probability, right? Total number of outcomes. That means out of 11, I am choosing 4. Yep. Last 2 questions of the day, guys. Can you look at this question, please? Take a minute. Yep, let's see this, guys. So if I have to take 11 steps and I have to be 1 step away from the starting point, now I can be in the forward direction or backward direction. So always remember, guys, if after 11 steps I have to be 1 step away from the starting point, I can take 5 forwards and 6 backwards, or I can take 6 forwards and 5 backwards. Clear? So which 5 out of the 6 I'm not aware of? So 11C5 into the probability of each forward step is 1 by 3. So 1 by 3 into 1 by 3 into 1 by 3 becomes 1 by 3 to the power 5. Clear? And 6 backward steps. So this becomes the remaining 6 are already left. So 2 by 3 whole to the power 6. This case, or 11c6 into 1 by 3 whole to the power 6 into 2 by 3 whole to the power 5. In both the cases, I would be one step away from the starting point. Is this point clear with all of us? Great. What's the answer for option question B? Question B, the answer is 0 because with even number of steps, you cannot be one step away from the starting point. You will have to be either 2 steps or 4 steps or at the same position and so on and so on and so on. Clear? With odd number of steps, if you observe, you can only be odd number of places away from the starting point. Let's see this for example. So forward and backward. If I'm taking 10 forward and 1 backward, I will be 9 steps away from starting point. Clear? 11, 0, you will be 11 steps away from starting point. 9 and 2, you will be 7 steps away from starting point. So you see with odd number of steps, you are odd number of steps away. Okay. Then you are looking at with 8 and 3, 5 steps away. With 7 and 4, 3 steps away. With 6 and 5, 1 step away. Similarly, reverse 5 and 6 also 1 step away. So we are looking at these two cases. But if you look at forward and backward as 10 steps, 10, 0, you are 10 steps away. Clear? 9, 1, you are 8 steps away. 8, 2, you are 6 steps away. 7, 3, you are 4 steps away. Clear? 6, 4, you are 2 steps away. Or you have 5, 5, you have 0 steps away. So look at the gap. The gap is always an even gap. So if you're taking even number of steps, you cannot be odd number of steps away from the starting point, and therefore the answer becomes 0. Clear, guys? One last question for the season. This is your last class also. So now what do I mean by odds for A winning the match? Now, whenever you write 2 is to 3, write 2 by 5 and write 3 by 5 here. Okay. Now the question says odds for A winning. So A winning the probability is 2 by 5 and A not winning the probability is 3 by 5. Is this point clear, guys? Now let's write B. 1 is to 4 అయితే 1 by 5 ఇంకా 4 by 5 అమ్మ. What is the question saying? Odds against B winning. Against B winning ఇది ఉందమ్మా. So against B winning means B not winning. So B not winning probability 1 by 5 and B winning probability 4 by 5 అయిపోతుంది. Similarly, odd against C losing. Let's say this is 1 by 5 and 4 by 5. Against C losing is nothing but C winning. So C winning is 1 by 5 and C not winning is 4 by 5. Is this point clear? Now, what is the probability that all of them will win? It's a very simple question. A wins, B wins, and C wins. So A wins, the probability is 2 by 5, B wins, the probability is 4 by 5, and C wins, the probability is 1 by 5. What is the probability that all of them lose? All of them lose will be A losing 3 by 5, B losing 1 by 5, C losing 4 by 5. What is the probability that at least one of them wins? So we have discussed at least one of them is 1 minus none of them winning. So 1 minus 12 by 125 becomes the answer for at least one of them winning. Clear? And the last one is exactly one of them winning. So I would say A wins, B and C do not, or B wins, A and C do not, or A and B do not and C wins. So A winning is 2 by 5, B not winning is 1 by 5, and C not winning is 4 by 5. A not winning is 3 by 5, B winning is 4 by 5, and C not winning is 1 by 5. A not winning is 3 by 5, B not winning is 1 by 5, and C winning is also 1 by 5. So this becomes your final answer. That's it, guys. So any doubts, please ask, else we are done with the complete syllabus. so far, and then we'll meet sometime in August, and then we will start discussing the remaining models or the higher level models which are required for Infosys and all the other examinations. Clear, guys? Any doubts, please ask. If not, it was great meeting you all, guys. And last day, so I just wound up a little early. So keep practicing, guys. We'll meet very soon. Don't worry about that. And let's ensure that we get great placements this time. When are the exams going to be conducted? Which exams, Nana? Course తర్వాత ఎగ్జామ్స్ అబ్బా ఎంత సీరియస్ రా అది నాకేం తెలుసురా